Okay, let us now proceed to component method in adding forces. So, let's start with the resultant of concurrent forces. Okay, by the way, what is a resultant force? So when speaking of a resultant force, this is a net force of a given force system. So in other words, this is a single force which replaces the given force system. Let us try to consider three forces acting on a particle. But before we proceed, what is a concurrent forces? So we're speaking of a concurrent forces, the line of action of all the forces in a given force system intersect at a common point. Now, let us try to consider three forces acting on a particle. So we now have your F1, so we have your F2, and this is now your F3. Now, the resultant force R of these three forces is equal to the vectorial sum of the three forces, F1, F2, and F3. So let us try to resolve the rectangular components of each force. Okay, so let's try to resolve each force by its rectangular components. So your R in here, in its Cartesian vector form, is now equal to Rx I plus, we now have your Ry J plus Rz K. Now similarly, your F1 is now equal to F1xi plus, we have F1yj plus F1zk. For the first F2, so this is equal to F2xi plus, we have F2yj plus F2zk. And for the first three, this is equal to F3xi plus F3yj plus F3zk. Hence, the resultant is now equal to, so we have Rxi plus, we have Ryj plus Rzk, and this is equal to, we have F1xi plus F1yj plus F1zk. So plus F2xi, F2xi plus F2yj plus F2zk. Then we now have plus, we have your F3xi plus F3yj plus F3 F3Z K. So this is therefore the resultant. Okay, so let's try to determine now the magnitude. So the magnitude of the resultant R. So to determine the magnitude of the resultant R, so let's try to get now the scalar components of R. So the scalar components of R. So that your Rx in here is now equal to F1x plus F2x plus F3x. So in other words, your Rx in here is now equal to the summation of forces in the x direction. And then we have now your Ry is equal to, we have your R1y plus F1y plus F2y, F2y plus F3y. So your Ry in here is now equal to the summation of forces in the direction of y. Now we have now your R's of z is now equal to F1 z plus F2 z plus F3 z. Hence, the magnitude or the scalar magnitude of our z is now equal to the summation of forces in the z direction. Now, to determine the magnitude of the resultant R is now equal to the square root of Rx squared plus Ry squared plus Rz squared. So let us try to determine now the angle that the resultant. So we now have the angle that the resultant makes with the positive x, y, and z axis. Now, so you try to take note in here now. If this is now your, this is your x, this is your y, and that one is now your z. So let us try to consider that this is now the resultant force. So I'm going to consider that this one in here is the resultant force R. Again, your R in here, this system of forces in here is now replaced by a single force known as the resultant. So if you're going to get now your theta x, so this is your theta x. So your theta x in here is now equal to the arc cosine of Rx over the resultant R. So this is now your Rx. And your theta y, it makes with the positive y-axis. So this is now your theta y. So your theta y is now equal to the arc cosine of r y all over the resultant r. So this is your r y. And your theta z, so this is now your theta z. So your theta z in here is now equal to the arc cosine of rz all over r. And this is now the component of r in the z direction, which is equal to rz. For a two-dimensional force system, so we have the x-axis and the y-axis. So how are we therefore going to determine the resultant of these forces? So your Rx in here is now equal to F1x plus F2x plus F3x. So again, your Rx in here is equal to the summation of forces in the x direction. So your Ry is now equal to F1y plus F2y plus F3y. In other words, your Ry is now equal to the summation of forces in the y direction. So let us try to determine now the magnitude of the resultant force. So how are we going to determine the magnitude of the resultant force? So now we have this is the x-axis, and this one in here is now the y-axis. So let's try to consider that this one in here is now the resultant of the given force system. This is now the component of the resultant in the x direction, and this is therefore the component of the resultant in the y direction. So we now have, using now your Pythagorean theorem, so we have the resultant R. This is the component in the x-axis. So we have your Rx, and we now have your Ry. So that the resultant force is now equal to the square root of Rx squared plus Ry squared. Now, how are we going to determine the angle that the resultant makes with the x-axis? Okay, so this is now the angle that the resultant makes with the x-axis, and let's try to consider that one as theta, the angle that the resultant makes with the x-axis, and that is now equal to theta with the x-axis. So if you're going to get in here now, so your tangent of theta is equal equal to Ry all over Rx. And therefore, the angle that the resultant makes with the x-axis is now equal to the arctangent of Ry all over Rx. For sample problem number 1. So find the resultant of the given system of forces using the component method. So we have 65 pounds, 88 makes an angle of 75 degrees with the y-axis, 88 pounds, 35 degrees with the x-axis, and 125 pounds, 45 degrees with the x-axis. Okay. So first, let's try to determine your Rx. So Rx is now equal to the summation of forces in the direction of x or along the x-axis. So we have now the x component. The x components of the three forces. So for the 65 pounds, now we have the x component, so that is equal to negative 65 because the x component is directed to the left. Okay, so the angle is not included with the x-axis and therefore it is sine of 75 degrees. Sine of 75 degrees. So this is equal to negative 62.78 pounds. Negative 62.785 pounds. Now for the 88 pounds, so the x component of the 88 pounds is directed to the right, hence this is positive. So that is 88 cosine, because 35 degrees is included in the x-axis of 35 degrees, and this one is equal to 72.085 pounds. And for the 125 pounds, again, the x component is directed to the right. So we have positive 125. Again, cosine of 45 degrees. And this one is equal to 88.388 pounds. 88.388 pounds. Now, so that your Rx is therefore equal to the summation of forces along the x-axis minus 62.785 plus 72.085 plus 88.388. So your Rx in here is now equal to, we now have your Rx is now equal to 97.688. That is 97.688 pounds. So again, you try to take note that we got a positive value. Therefore, Rx is directed to the right. Now, similarly, your Ry is equal to summation of forces, okay, along the y-axis. So we now have the y components of the three forces. So for the 65 pounds, then the y component of the 65 pounds is going up, so we have positive 65. 75 degrees is included in the y-axis, so that is cosine of 75 degrees. And this one is equal to 16.823 pounds. We now have the 88-pound force. Again, the 88-pound force y component is directed upward. So we have 88. We now have sine of 35 degrees. And this is equal to 50.475. 50.475 pounds. For the 125 pounds, so this is equal to 125. We now have a sine of 45 degrees. And this is equal to negative, because you try to take note that the y component of the 125 pounds is going downward. So you try to take note that to the right forces is positive, to the left is negative, upward forces is positive, and downward forces is negative. And therefore, this is equal to negative 88.388 pounds. Hence, your Ry is now equal to 16.823 plus 50.475 minus 88.388. And the component of the resultant in the y-axis is equal to negative 21.09 pounds. Or your Ry in here is now equal to 21.09 pounds. The negative sign indicates in here that the component of the resultant in the y-axis is going downward. So this is going downward. So let's try to determine, therefore, your resultant R. So the resultant R is now equal to the square root of Rx squared plus Ry squared. And this is therefore equal to the square root of Rx, 97.688 squared plus 21.09 squared. So this is therefore equal to 99.939 pounds. So we have 99.931 pounds. Now, the angle that the resultant makes with the x-axis. So we now have, this is your x-axis. And we now have your y-axis. Now, the component of the resultant in the x direction is going to the right. And the component of the resultant in the y direction is going downward. Hence, this is therefore the resultant force R. So, this is now the angle it makes with the x-axis. Hence, your theta is now equal to the arctangent of, so we have your Ry, that is downward. So this is now your Ry, and this one in here is now your Rx. So it's equal to the arctangent of Ry all over Rx. And the arctangent of Ry all over Rx is now equal to, so your Ry is 21.09 all over Rx is 97.688. And therefore, it makes an angle of 12.18 degrees, 12.18 degrees with the x-axis. Hence, therefore, the resultant R is now equal to 99.931 pounds. It is down, to the right. So it is down to the right. At theta with the x-axis equal to 12.18 degrees. Sample problem number 2. 3 ropes are tied to a small metal ring. At the end of each rope, 3 students are pulling each trying to move the ring in their direction. Find the net force. So that is the magnitude and direction. Again, when you're speaking of a net force, so that is the resultant. Or when the problem says replace the force system to a single force, then you are getting the resultant. And the ring due to the 3 applied forces. Again, we have let's try to get now, the component of the resultant in the x-axis is now equal to summation of forces along the x-axis. So we have your x component of each force. So have your force A. So we now have your AX. So the component of A in the x direction is now equal to, so that is going to the right. So it is positive 25 cosine of 37 degrees. Your BX is now equal to 70 cosine of 135 degrees. And your CX is now equal to 60 pounds. That is cosine of, that is 240 degrees. So this is, so this one in here is negative because the component of B in the x-axis is going to the left. Similarly, with the force C, so that is negative. The component of the 60 pounds in the x-axis is again going to the left. So it's 19.966 pounds. This is negative 49.497 pounds. And we have negative 30 pounds. So we now have your Rx is therefore equal to the summation of forces along the x-axis. So 19.966 minus 49.497 minus 30. So your Rx is now equal to negative 59.531. So it's negative 59.531 pounds, or your Rx is equal to 59.531 pounds going to the left. So let's try to determine now your Ry. And this is equal to the summation of forces along the y-axis. So we now have your y component of each force. So you have your Ay is now equal to, that's going upward. So your Ay is 25. So it's equal to 25 sine of 37 degrees. And this one is equal to 15.045 pounds. Then we have your By is now still going up. So that is 70. We now have sine of 135 degrees. And this one is equal to 49.497 pounds. And your Cy is now equal to 60. We now have sine of 240 degrees, and this one is negative 51.962. That is 51.962 pounds. Hence, your Ry is now equal to 15.045 plus 49.497 minus 51.962. So your Ry is equal to negative 12.58 pounds. Or your Ry is 12.58 pounds, and this is going downward. Let's try to determine now the magnitude and the direction angle of the resultant force. So the magnitude of R is equal to the square root of Rx squared plus Ry squared. So that is equal to the square root of Rx is equal to 59.531 square plus 12.58 square, so that the magnitude of the resultant is equal to 60.846 pounds. 60.846 pounds. Okay, so let's try to get now the angle it makes with. Okay, so if this is now your x-axis, that is your y-axis. So going to the left and going downward. So this is therefore the resultant R. And this is now your Rx. And this one in here is your Ry. So let's try to get now the angle it makes with the negative x-axis. And that is now your theta. So that again, your theta is now equal to the arctangent of Ry all over Rx. So this is equal to the arctangent. Ry is 12.58 58, the arctangent all over Rx, which is equal to 59.531. So your theta in here is now equal to 11.93. 11.93 degrees. So 11.93 degrees with the negative x-axis. Hence, the resultant, therefore, your R is now equal to 60.846 pounds. This is down to the left. Okay, so that is down to the left at an angle of 11.93 degrees with the negative x-axis. Negative x-axis, or you try to take note that this is the positive x-axis. So this angle in here is 180 plus your theta, which is equal to, so it's 180 plus 11.93, or that is equal to 191.93 degrees with the positive x-axis. Or this force system can be written in this manner. So have your H 25 pounds with 37 degrees with the positive x-axis. And your force B, which is equal to 70 pounds, having an angle of, so this angle in here is 180 minus 135. So that is 180 degrees minus 135 degrees, or that one is equal to 45 degrees. Or this one in here is now equal to, so this is your C, and that one is equal to 60 pounds. So we now have this angle in here is 240. So that this angle in here is now equal to, so we have 270. 270 minus 240 degrees, or this one is equal to 30 degrees. Now, we now have Rx in here is equal to summation of forces along the x-axis. Again, to the right forces positive and to the left forces negative. So we now have your Ax is equal to A, and that one is 25 cosine of 37 degrees. And then your Bx in here is negative 70 cosine of 45 degrees. And your Cx is equal to still negative 60 pounds. So this is now sine of 30 degrees. So this is equal to, so we have 25 cosine of 37 is equal to 19.966. So we have positive 19.966. So we have your 70 cosine of 45. So this is equal to 49.497. So negative 49.497 pounds. And then we now have your 60 sine of 30 degrees. So that is equal to negative 30 pounds. Okay, so we now have your Rx in here is equal to 19.966 minus 49.497 minus 30. And this one is equal to negative 59.531 pounds. Or your Rx in here is equal to 59.531 pounds, and this is now going to the left. Now similarly, your Ry is equal to summation of forces along the y-axis. So we have now your Ay is equal to 25 sine of 37 degrees. And 35 sine of 37 degrees is 15.045 pounds. Then we now have your By is equal to Dy, so that is going up. So we have positive 70. So we have sine of 45 degrees and 70 sine of 45 degrees is equal to 49.497 pounds. Your Cy in here is equal to, we now have 60 negative, that is going down. We now have cosine of 30 degrees, and this one is equal to negative. So we have 60 cosine of 30. So we have negative 51.962. 51.962. So we now have your Ry is now equal to 15.045 plus 49.497 minus 51.962, and this one is equal to negative 12.58 pounds. Or your Ry is equal to 12.58 pounds. This is going downward. Now, so again, the value of the resultant. So this is now your x-axis, that is your y-axis. So your R in here is equal to the square root of Rx square, 59.531 square, plus 12.58 square. So the resultant is equal to 60.846. So that is 60.846 pounds. So your Rx is going to the left. So we now have your Rx. Ry is going downward. So that is your Ry. So this is therefore the resultant R. So the resultant R makes an angle of theta with the negative x-axis. So your theta is now equal to the arc tangent of Ry, and Ry is 12.58 all over Rx, and Rx is 59.531. So your theta is now equal to 11.93 degrees. So therefore, your R is equal to 60.846. That one down to the left. Okay, at theta is equal to 11.93 degrees with the negative x axis. Okay, so we have sample problem number 3. So we have 3 forces up on the bracket as shown. Now, so we have the 3 forces. F1 is 450 newtons, F2 is 200 newtons, and F3. Determine the magnitude and the direction theta of F3 so that the resultant force is directed along the positive x prime axis and has a magnitude of 1,000 newtons. Okay, so this is the x-axis. This one in here is the y-axis. So this is now your x prime, and this one in here is now your y prime. So we are required to now take note in here that the resultant is equal to 1,000 newtons directed. Okay, so this is directed along the positive x prime axis. So we are required along the positive x prime axis. So let's try to determine the components of each force in the direction of x prime and in the direction of y prime. So we have now, so if this one in here is now your, okay, so this is now your x prime, and this one in here is now your y prime. So this is your x prime, and this one in here is now your y prime. So we have your F1. So we have F1 in here. So this is now your F1. So this is F1. And your F1 is now equal to 450 newtons. So it makes an angle of 45 plus 30. So that is 75 degrees. So that is 75 degrees with x prime. Again, so we have again your y prime, and this one in here is now your x prime. So your y prime and that one is x prime. So the 200 newtons is 30 degrees with x prime. So this is the 200 newton force. So we now have 200 newton. So this is 30 degrees with the x prime. So let us try to determine now the resultant along the x prime axis. So your Rx prime is now equal to the summation of forces along the x prime axis. So Rx prime is now equal to, so we have, so this is going to the right, the x component. So we have 450 cosine of 75 degrees. So this is your f1x. Okay, so I'm just going to place it in here. So this is your f1x. And then your f2 is still going to the right. The component in the x prime direction is going to the right, plus. So we have now your f2x. And this is equal to 200 cosine of 30 degrees. And then plus f3x. So plus your f3x. So plus your f3x. So that is now the resultant in the direction of x prime. So your ry prime is now equal to the summation of forces in the y prime direction. So we now have your ry prime is equal to, so the component of the 50 is going up. So we have 450 sine of 75 degrees. So that is your f1y prime. That is your f1y prime. That is okay. Similarly, this is going up. So we have plus. We now have 200. We have sine of 30 degrees. That is now your f2 in the direction of y prime. Plus, minus, okay? So your f3 is directed down to the right. So we have minus f3y prime. So we have f3y prime. Okay, so that is now, therefore, the equation. So we do not know f3x prime, and we do not know f3y prime. Now, so let's try to go back in here. So this is therefore your x prime. And then we now have your y prime. So this is now your y prime. So the resultant R, which is equal to 100 newtons, is directed along the x prime axis. So this is now the resultant R, and that one is equal to 1,000 newtons. So now since R is along the x prime axis, then your Rx is equal to R is equal to 1,000 newtons. Hence, this directed along the x-axis, then it has no component in the y. So, your Ry prime is therefore equal to 0. So we now have, I'm just going to consider this as the first equation, and this is now the second equation. Okay, so we now have from equation 1, Rx, which is equal to 1,000. So that is directed to the right, is now equal to 450 cosine of 75 degrees plus 200 cosine of 30 degrees plus f3x prime, so that your f3x prime is therefore equal to 7. Now, so this is equal to, okay, so this is 1,000 minus 450 cosine of 75 degrees minus 200 cosine of 30 degrees. And this one is now equal to 710.326. 710.326 pounds. And then from equation 2. So this is your equation 2. So we now have 0 is equal to 450. We have sine of 75 degrees plus we have 200 sine of 30 degrees minus f3y prime. So your f3y prime is now equal to 450 sine of 75 degrees plus is 200 sine of 30 degrees. So this is equal to 534. So that is 534.667. Okay, 0.667 Newton. So that one is in newtons. Again, your f3x prime, so that is now your f3x prime. So that is equal to 710.326 newtons. And this one in here is now, so this is now your F. So this is your F3y prime, which is equal to 534.667. 534.667 newtons. So let's try to determine now the magnitude. Okay, magnitude of F3. So your F3 again in here is now equal to, using Pythagorean theorem, so this is equal to the square root of 7F3 prime, F3x prime is 710.326 square plus 534.667 square, or this is equal to 889. So 889.062 newtons. And the angle theta with the positive x prime axis is now equal to the arc tangent of f3y prime all over f3x prime, and this is therefore equal to 534.667 all over 710.326. Hence, your theta is now equal to 36.97 degrees. That is sample problem number 4. determine the magnitude of the force F so that the resultant force R of the three forces is as small as possible. What is the minimum magnitude of R? So first, let's try to determine the component of the resultant along the x-axis. So your Rx is equal to summation of forces along the x-axis. So your Rx in here is now equal to, okay, the 5 kilonewton force is directed along the x-axis. So that one is equal to 5. And then your F is directed up to the left. So we have minus F sine of 30 degrees. That is F sine of 30 degrees. Now, the 4 kilonewton load has no component. The component of the 4 kilonewton load in the x-axis is equal to 0 because it is directed along the x-axis. Let's try to determine now the value of Ry. Again, your Ry is now equal to summation of forces along the y-axis. So your Ry is now equal to, okay, we have 4 kilonewtons. So it is directed downward. So that is negative 4. And then we have this going up. So that is plus F. We now have cosine of 30 degrees. Cosine of 30 degrees. Again, the 5 kilonewton load has no component in the y-axis because again, it is along, in the y-axis because this is again along the x-axis. So this is therefore equal to 5 minus 0.5 F, and this one is negative 4 plus 0.866 of F. Now, the value of the resultant R is now equal to the square root of Rx squared plus Ry squared. So, in other words, your R squared is now equal to Rx squared plus Ry squared. R squared is now equal to, so we have 5 minus 0.5 F, so this is square, plus minus 4 plus 0.866 F, and this one in here is squared. Now, to determine the minimum value of R, okay, so to determine the minimum value of R, let us try to set, okay, the first derivative of R with respect to F. Equal to 0. So, let's try to determine now the derivative of r squared. So we now have 2r. So we now have your dr all over df is now equal to, so we have 2 multiply this one by 5 minus 0.5 f multiply this one by negative 0.5. So we have plus, we have 2 multiply this by negative 4 plus 0.866 f multiply this one by 0.866. Now, we set the first derivative of r with respect to f equal to 0. So, substitute this value in this equation. So, we now have 0 is now equal to we have 2 times 5 times negative 0.05. So that is equal to negative 5. And then 2 times negative 0.05 multiply this one by negative 0.05. So that is plus 0.5 f. 2 times negative 4 by 0.866. We have negative 6.928 minus 6.928. 2 by 0.866 by 0.866. So this is equal to 1.5 of f. That is plus 1.5 of f. The 0 is now equal to 11.928. 0.928 plus 2f. Hence, your f in here, 2f is equal to 11.928. So the value of f is 11.928 all over 2. And this is therefore equal to 5.964. 5.964 kilonewtons. Let's try to determine now the value of r. So we now have to determine now the value of r. So the value of r in here is equal to, from this equation, so if I'm going to call this one as first equation, so from equation 1, so we now have your r squared is now equal to, so this is 5 minus 0.5. The value of f is 5.964. So this is square. And then we have plus, we have negative 4 plus 0.866 multiply this one by 5.964. And this one in here is a square. So your r square is equal to 5.431 kilonewtons, and therefore your R is now equal to the square root of 5.431, and the value of R therefore is now equal to 2.33 kilonewtons. Insya na dito, insya natin kas gaya kumbik. Madimitan. Coba ang pindutin ko, nagkas-limitan ni Hanan samit na ala.
Wait lang, sir. Ay, hindi. Cancel.
Paano ka
No.
nag-sound tata?
Ay, sige, sir. Ongoing.
Ongoing dito yan.
One, sir.
Okay. Nalpasen.